All right, applications of sinusoidal functions, part 2, spring 2020. So, an equation must be determined before we can answer any of the questions regarding the relationship, right? So you remember all of these parameters here, right? So I start with D. So D is the median, or the mid, excuse me, or the midline. It's the average value, actually the middle value of the sinusoidal function. And the equation of the mid, just ignore them, you're going to hear them. The equation of the midline is y is equal to d. A is the amplitude. A is for amplitude. The amplitude is half the difference from the maximum to the minimum. So let's say we had a midline here. And this is the value of A, which is also half the difference, half the distance from max to min, right? So you could say that A is equal to max minus min divided by 2. And D, actually, so D is equal to max plus min over 2. B, not the period. So the period is equal to 2 pi divided by B, or B is equal to 2 pi divided by the period. So depending on which one we have, if we have the B, then we can calculate the period, and if we have the period, we can calculate the B value. And C is the phase shift. So that's our left or right. All right, example 1. The maximum tidal height at a port on the east coast of Nova Scotia is 4.2 meters at 6 a.m. The minimum tidal height is 1.2 meters at 12:15 p.m. Okay, I'm changing this. I'm going with nice numbers. We're just going to make that 12 p.m. so that it can be 6 hours. The relationship between the tidal height, h in meters, and the time t in hours. Sketch a graph for the height as it relates to time. Okay, so we are going from 4.2 meters to 1.2 meters. So I'm just going to make that 0. We'll put in 1.2. If that's 1.2, that's going to be like 2.4, 3.6, 4.8. So we'll call this 4.2. At 6 a.m., so this is 0, so we'll go with 6, 12. What if they want 2 full cycles? 18. That's a bit too far. 24. 30. Is that going to give us 2 cycles? So if we have a max height at 6 a.m. and a minimum height at 12 p.m., that's half the cycle. Then what I really want to know is, where is the middle? So D, basically the average, right? The middle, the median. Max plus min, so 4.2 plus 1.2 over 2, which is 5.4 over 2, or 2.7, and it's in meters. So that's going to be in the middle. Let's just sketch that in. I always like to have the midline sketched in. All right, there's 2.7. So if it took 6 hours to go from the max to the min, then each chunk is 3 hours. So by chunk, remember we divide a sinusoidal function into 4 parts. So 2 of those parts are 6 hours, which means 1 part is 3 hours. So 3 hours later, at 15, we'll be back to the middle, and at 18, we'll be at the max, and at 21, we'll be back in the middle, and at 24, we'll be at the min. And now we have 2 complete cycles. Starting low, and sketching, and there we go. 2 full cycles. Check. This is height in meters. This is time in hours. So it would be the t-axis and the h-axis. Okay, what do we want to know? Determine the equation that best represents in each of the following forms. Well, as a cosine function, we can just say this would be a very nice reflected cosine function. So, h of t is equal to a. Now, did we figure out a? So a is max minus min. So it's the difference between high and low divided by 2. Which is 4.2 minus 1.2 over 2. 3 over 2, or 1.5. And what else do we need? We need b. So we need to know the period. So the period would start at 0 and go to 12. So we know half the period is 6 hours. So the full period is 12 hours. So period is 12 hours. And b is 2 pi divided by the period, which is 2 pi over 12, or pi divided by 6. Okay, so 1.5 cos pi over 6 t. Now, there's no phase shift, right? Oh, if we make this negative, there's no phase shift. So as a reflected cosine function, there won't be a phase shift. And the d value plus 2.7. Now, if we do this as a sine function, and we know the only difference between a cosine function and a sine function, so negative 1.5 sine pi over 6 t, and the only difference will be that in this case, there will be a phase shift. So the smallest phase shift would be 3 hours to the right, and that would give us a positive sine function. So let's just get rid of that. So it's a positive sine function. We need to go right 3, so minus 3. So as a cosine function, we can get away with no phase shift, 0 phase shift, if we just do it as a reflected cosine function, and as a sine function, just a regular sine function, and we're shifted right 3 units. And we get both of these equations. Graphically determine the first time after 6 a.m. that the tide height is 3 meters. Okay, graphically determine, which means we need the equation, and it doesn't matter which equation. As a matter of fact, I'll type them both in. We'll see that they're exactly the same. So let's turn this on. Let's go to y equals, clear whatever's in there. Clear. Okay, so let's go. Negative 1.5 cos. So pi over 6. I need to get fancy here. Oh, I can't tap on that. Pi over 6. So second pi divided by 6. X. Don't need any brackets there because plus 2.7. And we can graph the other one as well. Just they're the same, so it really doesn't matter which one we use. Sine, okay, but now, here, we'll get less fancy this time. So we'll go pi divided by 6. Then we want x. We needed to go right 3, so x minus 3, Okay, we'll close off that bracket. Plus 2.7. Now we want the first time after 6 a.m., so I think 1 cycle will do. So let's set up 0 to 12. Looks good. And what were our tide heights? So got 2.7, we got 1.2 to 4.2. So let's go 0 to 5. 0 to 5. So when I graph these, the first one in blue is the cosine function. And the second one will be in red, and that will be the sine function. And all you're going to see is the red will overwrite the blue. And what did we want? So the tide height, we want it to be 3 meters. So determine the tide height, the time, first time after 6 a.m. So 1, 2, 3, 4, 5, 6 is here. And what we're going to do, I'll put in Y3. The tide is 3 meters. So we're looking for this right here. Okay, because this is midnight. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's around 9-ish. Graphical determine. All right, so I'll just do this up here. So Y1 is, let's go with the cos function. -1/6. Pi over 6 x plus 2.7. And in my case it's y3, but we could call it y2. And we graph this. And we got this. We need our windows. So if we're doing graphical stuff, basically we want somebody excuse me, to be able to duplicate our work. So what we see here should duplicate. Okay, now that's 6, so we want this. Second calc intersect. And in the calculator, second calc intersect. And I'm just going to trace down this. And hit end. Oh, now wait a sec. So that's first curve. So because I've got y2, I want this to be y3. So because I entered them both, you'll only enter 1, so you wouldn't have to worry. But I just got to make sure that's y3. And the intersection is 8.615. So 8.62. Well, 8.615. 4347. And now if we're talking time, so we know what to do with that, right? So I'll quit out of this. I'm going to go x. Oh, let's clear this. So let's go x minus 8, right, times 60. And we get 8. So in the clock, it's going to show us 8:36, right? Because it's 36.9. You know, but if we round, we can say 8:37. You know, if you wanted to get more, we can subtract that 36 and multiply the decimal seconds by 60 to get seconds. So it'd be 8:36.55. That's what it would show. And that's our first one. Okay, so we're taking the information, we're using that to make a sketch, and from the sketch, the labeled sketch, we can, you know, figure out most of our stuff. Let's try again. During deep sleep, a person's breathing can be very regular. The volume of air in the lungs follows a sinusoidal relationship that varies from 1,000 milliliters to 5,000 milliliters over a 5-second interval. Sketch a graph representing the volume as it relates to time. If at the moment the person enters deep sleep, the volume of air in the lungs is 3,000 milliliters. Okay. So, let's say we got 1,000, that'll be 2,000, 3,000, 4,000, and 5,000. So that's volume in milliliters. And this is time in seconds. So this is actually our midline, right? Because it's halfway between. So over a 5 sec varies from 1,000 to 5,000 milliliters over a 5 second interval. So it takes 5 seconds to go from 1,000 to 5,000. And then it's going to take another 5 seconds to go back down to 1,000. So the period would be 10 seconds. And B will be 2 pi over 10. So our B value is pi over 5. D is max plus min over 2. So 5,000 plus 1,000 over 2 is 3,000. A is max minus min over 2. So 5,000 minus 1,000 over 2 is 4,000 over 2, or 2,000. If the period is 10 seconds, then stuff happens in 2.5. So 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20. So 2.5, 5, 10, 15, 20. So at the moment they enter deep sleep. Now we can actually go either way, right? It doesn't really specify, but let's be inspired. We'll say it's inspiration. And remember, the period is 10 seconds, so the amount period is split into 4 parts, so it takes 2.5 seconds to get up to the maximum, 2.5 to get back down, so it'll be 5 seconds, then another 2.5 to get to the minimum, and then another 2.5 to get back to the middle, 2.5 to go back up to the maximum, 2.5 to the middle, to the min, back to the middle. And it varies from 1,000 to 5,000 over a 5 second interval, right? So from 7.5 at 1,000 to 12.5 at 5,000 will be that 5 second interval. Sketchy, sketchy. Okay, and there's our 2 cycles. And while we were doing all of that, we have everything, right? Now, if you ask me, and I haven't looked ahead, but if you ask me to give an equation, I would go with the sine function because there would be no phase shift. And if we had gone down, if we thought they were breathing out instead of in after the first 3,000, then I would have gone with the reflected. So determine an equation. Okay, an equation, right? All right, so we're good. V of t. Determine. We've got the work all over here. So A, 2,000. Sine B, so pi over 5 t. So as an unreflected, it's just a normal sinusoidal curve, right? It starts at the midline going up, plus 3,000. So that's our equation. Now again, if you had it going down, you would have a different equation, right? You'd have the negative sign. If a person falls into a deep sleep at exactly 1 a.m., then algebraically determine the volume in the lungs at 1:10 a.m. Okay, so that's 10 minutes later. And 10 minutes is 600 seconds. Right, so we want the time at 600 seconds. Now, if we just think about this before we do anything, if the period is 10 seconds, then we'll simply have gone through 60 periods. So at 1:10 a.m., we'll have gone through 60 periods, and we will be right back at 3,000. Let's put it into the equation. So V of 600 is 2 1000 sine pi over 5. Now, what the pi over 5 is doing here is it's going to convert the seconds. See, if I had to put 10 seconds in here, pi over 5 times 10 would give us 2 pi, right, which is 1 period. It's going to convert the seconds into radians, plus 300. Okay, so boom. That gives us 120 pi. Now, that's a multiple of 2 pi, so it's the sine of 2 pi, which is just going to be 0. And we've got 3,000 milliliters. At 1:10 a.m., 60 seconds, right? Which is really just 60 periods. A small child holds a small slinky and lets it oscillate up and down. In full expansion, the bottom of the slinky is 1 foot above the ground. At full compression, the bottom of the slinky is 3.5 feet above the ground. Determine an equation relating the height of the bottom of the slinky to time. If at t equals 0, the slinky is in full expansion, and it's in full compression 3 seconds later. All right, so always, always, always draw a picture. So full expansion, it's hanging down. It'll be 1 foot above the ground, and full compression. So if that's 1, call that 2, call that 3, call that 3.5. So d max plus min over 2. So the max height is 3.5 over 2. That's 4.5 or 2.25. So 1, 2, 1/4. So there's our midline. That's 2.25. Our amplitude, pretty obvious, it's 1.25, right? But if we want to calculate it, max minus min over 2. 3.5 minus 1 over 2. So that's 2.5 divided by 2, or 1.25. And we go from full, okay. So if at t equals 0, the slinky is in full expansion. Okay, so in full expansion. So at time 0, it's down at the bottom. And it's in full compression 3 seconds later. So that's going to be a half a period. So 3 seconds, it'll be here. That's half a period. So at 1.5 seconds, it's going to be here. And basically, the period, so the period is 6 seconds, which means B is 2 pi divided by 6. So B is pi over 3, right? Now we've got everything. And we do not have the phase shift, but again, if I do this as a reflected cosine curve, then there would be a 0 phase shift. But let's finish drawing this out. So that's 4.5 seconds. I'm not going to label that. We'll just go 6, 7.5, 9. Let's go to 12. That'll give us 2 complete 10.5 and 12. Okay, so a second and a half later, we're at the midline, and 1 period, 6 seconds. We're here, and here, back to here, down to here. So we're starting at the bottom, going up. Wow. And that should be rounded there. That should not be a V. Don't V your sinusoidal graphs. Okay, so let's get an equation for this. So H, let's call that H, call that T. This is height in feet. This is time in seconds. Okay, so H is A. Sine, don't want sine. I change that to a cos. Cos, what? I want it reflected, negative 1.25 cos pi over 3 t t. Okay, so no phase shift, right? If we want a phase shift, we could do it as a sine function. It would be a positive sine function, and we'd be putting minus 1.5, right? T minus 1.5. Plus the midline 2.25. Okay, algebraically determine, let's call that h of t. H of 7 is negative 1.25 cos pi over 3 times 7 plus 2.25. Okay, so negative 1.25 cos 7 pi over 3. So we should be able to do that. So 7 pi over 3 is actually coterminal with pi over 3. So it's just going to be pi over 3. The cosine of pi over 3 is 1/2. Plus 2.25. So it's negative 0.6. 2 into 1.25. 6, 12, 0. Bring out the 5, 2, 4, 1, 0. Negative 0.625 plus 2.25. All right, I'm just, ouch, getting my calculator out. Plus 2.25, 25. And we get 1.625 equals 1.625 feet. Let's see if that actually matches up with our graph, right? So that's 6. What are these guys? They're 1.5 seconds. So that's 7.5. So 7 seconds there. Like, you know, that's not way out of line. 1.625 actually, and rounded to the nearest tenth. So 1.6 feet at 7 seconds. Sorry, I'm running off my tablet. 7 seconds. Next, a Ferris wheel has a radius 5 meters, so it's a pretty small Ferris wheel. And its lowest point is 0.5 meter above the ground. Sam gets on at the bottom of the Ferris wheel. His lowest point is 0.5 meter above the ground, and Sam gets on at the bottom. And it takes 8 seconds for Sam to travel from the bottom to the top. So the radius is really amplitude. Right? Think about the radius of a wheel. So I can draw a wheel. Here's a wheel. There's the radius. Okay, well, that's half the distance from max to min, right? So 5.5 is going to be the middle, right? If the radius is, hang on, I'm just trying to dash this line in there. If the radius is 5 meters, then the radius is the distance from the center, which on a Ferris wheel would be the hub, to the edge. And then our max will be 10.5. So, okay, wait, that's not actually a point there. And it takes 8 seconds to travel from top to bottom. So 8 seconds, and then he's at 10.5, which means 4 seconds he's in the middle, which means 4 seconds later he's back at the middle, which means 4 seconds later he's at the minimum, and then to the middle, and then to the max, and then to the middle, and then to the min. Right? So remember, a period is split into 4 parts. So this period is, so the period is 16 seconds. A little bit out of order here, but hang on, we'll just drag over and fill in the table. 12, 16, 20, 24, 28, 32. I find it easier to work off the graph actually than. So 0.5 to the middle, 5.5 to the max, 10.5, back to the middle, down to the minimum, back to the middle, up to the max, oops, back to the middle, and down to the min. And if we sketch that, and there we go. State the equation. All right, so we're just stating, so we know that a is 5 in this form, a sine. Okay, so for a sine function, it's going to be right 4. So h of t is equal to a. So a, the amplitude, is the radius, 5. Sine b, so usually we throw a square bracket down there. So we know that the period is 16 seconds. So 2 pi, so b is 2 pi over 16, right? So period is 16, right? From the min to the min. Pi over 8. T minus, because we're going right, so t minus 4 plus d, which is the, in this case, it's the height of the hub, or the center of the wheel. So describe how A and D relate to the Ferris wheel. So D is the height of the center of the wheel, which is the axle or hub. And A is the amplitude, which is the radius, of the Ferris wheel. Determine the height of a rider at 9.3 seconds. So that is not going to be a nice number. So we can just use our calculator. H of 9.3 is 5 sine pi over 8 t, 9 minus 3, plus 5.5. Okay, so calculator. Let's clear this out. Check. Mode is radians. Okay, 5 sine. I get fancy again. Pi divided by 8. Let's just put in what we wrote, 9.3 minus 4. We could very easily have just put in the 5.3 there. And we get 9, round answer to the nearest tenth, 9.9 meters. Alright, does that look reasonable? Let's go back up and look at our graph. So at 9 seconds, yeah, that's 9, there's 9.9 meters, about there. Right, it's not a very straight line, but that could be 9 seconds. I'd believe that if you told me that. Use your graphing calculator to determine how long a rider is 9 meters or higher in one full revolution. Alright, so remember, graphing calculator. So we need x minus 4. y2 is going to be 9. Graph is going to look like the graph up above, but just do it in my calculator. Dang, I entered that already. It's too bad I can't copy that over. Okay, so number one is clear out this stuff. Okay, so 5 sine pi divided by 8 bracket x minus 4, right, 4, close bracket, plus 5.5, and y2 is 9. Alright, so what do we say? The period was 16 seconds, so during one revolution, so we really only need to go to 16, but let's go to 32. We'll look at 2 cycles. And then let's do 4 here, because that's what the graph is split into. And let's go 0, and we say the top is 10.5. Let's say 12. So when I hit graph, this should look like the graph we have up here. And it pretty much does, right? So we're starting down at the bottom there, rising up. So the time in one cycle, and then, because we did 32 seconds here, then we should have like 2 complete periods pretty much, and we do. So let's show our x. 0 to 32 by 4. Let's show our y's. 0, we went up to 12 by 1. Let's sketch the graph. Tailing off, right? And what we want is this and this, right? Second calc intersect. So second calc intersect. I'll just go around. Actually, no, we'll do this one first because it's the larger number. Whoops, hang on. And enter, enter, enter. So we've got 10.025. And one, two, three, 5.97, 5.975. Now we can do that. 5 minus 5 is 0. That's gonna be what is that, 5? 0, 4. All right, let's say they made calculators for a reason. So 10.025 minus, and I think the x is should be the last x I had, right? So 4.050, so 4.1. So hide. And let's go, oops, here. So we got 4.1 seconds. So in one revolution, right, from here to here, one revolution, we have 4.1 seconds where you are above 9 meters. Okay, so next one's an exercise. I would say pause the video here, work your way through this, and then I'm just going to kind of go through and complete it. So I might scribble on this while you're away and then come back and just discuss it. So stop the video and go do this. So what I'm showing here is just my first scribblings on this before I even really look at any of the questions down there. I can figure out that the maximum height is 20, the minimum height is 1, d is max plus min over 2, which is 10.5, and so I'm just going to sketch in the midline. D is 10.5. Right, the equation of the midline would be y equals 10.5, right? The amplitude is the distance from 10.5 to 20, which is 9.5, or 20 minus 1 over 2, right? Max minus min over 2 is 9.5. So I've got the amplitude. So I've got D, I've got A. The period is 100 seconds, so I'm just going from a minimum to a minimum, right? So basically from when the ride left the ground, if you were the last one on it, it started actually moving, to when you return 100 seconds later, almost 2 minutes. All right, let's go start to answer some questions then. Determine the height of the hub. So the height of the hub, well, the hub is the midpoint is 10.5 meters. The radius, 9.5 meters, right? So, I mean, for that stuff, see above. Period is 100 seconds. Okay, so you notice it says state. So the determine, that's up here, right, for both of these guys. So height, let's answer this really in English. Height of hub, 10.5 meters. Radius of wheel. So the radius is the amplitude, or the amplitude is the radius. Radius of wheel, 9.5 meters. Determine an equation in the form a sine. So if we want to do this as a sine function, so as a sine function, it's midline going up. So this will be 20-second phase shift, right? 20 to the right. So we already have everything else. So h of t is 9.5, that's a, sine, so they want us 2 pi over the period, so 2 pi over 100, there should be a bracket there, I think, t minus 20, because it's 20 to the right, plus d, which is 10.5. As a cosine function, there's no phase shift. So h of t is equal to 9.5 cos 2 pi over 100 t. Okay. Oh. Okay, it didn't say. So actually, I'm going to make that negative. I'm going to clean that up. So I'm going to make that negative. So negative. So h of t equals negative 9.5 cos 2 pi over 100 t plus 10.5. Kind of a different question. A Ferris wheel has a radius of x meters. The center of the wheel is y meters above the ground. This is a is equal to x. This is d is equal to y. And it takes w seconds to complete one full revolution. If the rider starts at the bottom, write an equation in the form h of t with height in meters. Okay, so as a sine function, so let's do this here. So as a sine function, what have we got? So radius of x meters. So radius is amplitude. Sine 2 pi period, so it takes w seconds for one complete revolution. W bracket t, okay, let's leave this for a second, plus y. Alright, so what we now have to figure out, if it starts, rider starts at the bottom, then it's going to be 1/4 of the period, right? So, it takes you know what? This is 25. My bad. Okay, let's go back. Where are we? 25. Yeah, right? Just saying 1/4 of the period and then thinking, how did you come up with 20 there? So the period here is W, right? Half of W to get up to the max, and 1/4 of W to reach here. So starting at the bottom. So it's going to be right 1/4 of W. So minus W over 4 as a cosine function. So we'll do it both ways. If I can do it as negative, I will, because there won't be any phase shift. Cos 2 pi over W t plus y. And if I'm going to do a phase shift, so let's say we want to have that as positive. So still 2 pi over W t. So what I'm going to do is I'm going to go to the right half a period. See, 50 seconds in this case the period is, so we'll go right half a period. So minus period W over 2 plus y. Okay, and that's the solution to that. Now I have to get rid of that page. Okay, so those are the exercises, and then, continue on with questions, and, good luck. Any questions, email, etc., etc. And we'll put a stop to this now.